Assalamu alaikum. Traditionally, the results in the medical literature has been presented in the form of either significant or not significant based on the calculated p-value, which reflects the possibility that these results could have arisen by chance or not. There are limitations to this approach using the p-value. And this presentation will go through these limitations and will also touch on the alternative way of presenting results in the form of effect size and confidence intervals. We start by this example from real-time figures. We were analyzing the effect of several factors on the recurrences of pleomorphic adenomas of the parotid. Among these factors were the gender. So we had two groups here, the females and the males. The females were 112 and the males were just 70. And the recurrences in the female were 4 recurrences and in the male were 3. And so to establish whether this difference is significant or not significant, we try one of the simplest statistical tests, the chi-square test, by a 2x2 table where we have all the figures here. When we calculate the difference between the expected number of recurrences if there is no differences and the actual number of recurrences, and add up all the differences in the 4 cells, and if the added up chi-square figure exceeds a certain limit, a cut-off point, then it is deemed significant, and if it is less, it is not significant. And when we run the chi-square test, it produced this, and at 1 degree of freedom, the p-value was 0.807. That's not significant. End of story. Significant or not significant will be based on a probability distribution related to the area under the curve. In this situation, we would be trying to see if there is a difference between the expected numbers of recurrences per gender and the actual number of recurrences, and if the whole differences in the 4 cells exceeds a certain limit, then it is so rare, it may be in this area here, where we have only 5% of the figures. So we would say that this is very odd, this is very high, this is very rare, it is significant. If it exceeds that point, the p less than 5%. And that's exactly what the chi-square test would do. It would add up all the differences between the expected, if there is no difference, and the actual figures, and the added up figure was this. This was the chi-square figure for such a situation. And if you check this into the probability distribution, then you could see whether it is very rare or very odd or very high or not. The chi-square probability distribution is not necessarily a normal distribution, particularly for small degrees of freedom like 1, 2, or 3. The degrees of freedom, if the degrees of freedom is 1, this would be the probability distribution of the chi-square test, with a cut-off point here at the 5%, which measures more than 7 point something. Now, if the calculated chi-square for any test with 1 degree of freedom is less than this, then it is deemed not significant, as is the case here. It's quite a small differences between the actual and the expected numbers if there is no difference in recurrences related to the gender. That's why the p-value was quite high. This is about 8%, and it was deemed not significant. So that's one limitation for presenting results in the form of a p-value. If the p-value is non-significant, We really don't know whether there is actually no differences in the rate of recurrence between males and females, or that we had too few number of patients to demonstrate a real difference. That is to say, a false negative rather than a true negative result. In order to tell whether we have enough power to decide whether there is a difference or not, we need to do power analysis for the study and determine the numbers of patients required in order to show up a difference, if there is actually one. The other thing about the p-value is that it is a single cut-off point. We choose a point, traditionally 5%, and say that anything less than 5% is significant and anything more is non-significant. So very small variations around the 5% could change a decision from significant to a non-significant and vice versa. To add to this, why always make the question a dichotomy, right? Like significant or not significant, effective or not effective, when in actual fact it's a continuum rather than a dichotomy, rather than one or two. Back to the example, the results of the p-value showed that there is a non-significant differences between males and females and the recurrence rate. In matter of fact, the odd ratio, the calculated odd ratio, is 1.2. That is to say, the chance of females getting a recurrence is higher than males by 1.2. And the confidence intervals for this odds ratio goes up to almost 6 times the chance for females getting a recurrence to less than 1/4. So there's a wide confidence interval with a mark in the middle, the odds ratio, and this actually gives you a better picture about what is happening in relation to recurrences of pleomorphic adenomas with the gender than just saying yes, it is significant or no, it is not significant. There are alternative ways of presenting results rather than the p-value. One of these ways, which is gaining popularity, is the effect size plus or minus the confidence interval. And the effect size actually quantifies, measures the difference between the two groups being studied, and in terms of the differences between their means and divided by a certain standard deviation. And this would give you a correct estimate about the difference between the two groups, combined with a range, combined with confidence intervals about that estimate. And that gives you a much better and clearer idea about the results than just a cut-off point which says significant or not significant. So it also, by giving you a ratio or a quantified effect, it tells you how clinically significant the difference is rather than just being statistically significant or not. Because sometimes statistically significant results may not be clinically meaningful. There are several ways of measuring the effect size, including, for example, the difference between the mean of the two groups divided by a certain standard deviation, a combined standard deviation of the two groups. And there are also the way of measuring how much overlap between the two groups is. So if you have, for example, an overlap of about 50% of the readings between the two groups, this is a big difference here, because the difference would correspond to at least one standard deviation between the two means. And such results could give you an idea about how clinically significant the differences is. One other way of estimating the effect size is to see how many of one group is less than the mean of the other group, than the middle of the other group. And if there is only 50% of this group less than the mean of the other group, then you could imagine that the two curves are actually superimposed on each other, and there is very little differences between the two. Whereas if you have something like 70 or 90, 70 to 90% of this group less than the mean of this group, then there is a large effect size, and you can quantify it to 1 or 1.4 or 1.2. One more thing about the p-value is that the statistical significance does not equate to clinical significance. This is again a power distribution curve, and it shows that if you could have too many patients, if the study is very big, if you have thousands of patients into your study, the power would increase so much as to see very slight differences between two groups. These very slight differences may not equate to clinical significance, but because the power has increased dramatically with the increase of the number of patients in the experiment or in the study, then you can see very small, clinically non-significant differences, and these very small differences would be deemed statistical significant. In the next presentation, we'll go through the effect size in more details. But at this stage, just a reminder that the effect size is actually the currency we use in meta-analysis. What we do in meta-analysis when we combine results from different studies across the world is that we try and calculate the effect size of each study together with its confidence intervals, and try and see if these confidence intervals crosses the line of no differences, and then we add up all the effect sizes together and come out to a final conclusion at the end. So one very striking benefit of the effect size is that it is meta-analyzable. It can be used in conjunction with other studies to reach a decision. By this, we come to the end of this presentation on the limitations of the p-value in presenting results. The next presentation will be on the alternative way of presenting results, the effect size, and the confidence intervals. Assalamu alaikum.